Now, that's the orthographic projection. So what is the difference of this from the pictorial projections? So the projections in which the description of the object is completely understood in one view is known as pictorial projection. They have the advantage of conveying an immediate impression of the general shape and details of the object, but not its true dimensions or sizes. Pictorial projections may be of two types, as the axonometric and the oblique. So the axonometric is the we have mga types dyan. We have three types there: the isometric, dimetric, and the trimetric. But in this type of parallel pictorial projection, in which an object appears to be rotated to show its all three dimensions. So axonometric projections are classified according to how the principal axes are oriented relative to the projected surface. Okay, so we have here, this is the isometric, which is the usual nating gagawin. Okay, and there, 30, 30. Okay, we will use the 30 by 60 by 90 triangle. Dimetric ganun din, but it's 15 degree. Okay, 15 degree. Dito sa lower. And trimetric, 15 degree and 35 degree. So, yan yung that's why we really need protractor for this. Okay? Okay, so let's learn about the oblique projection. Pag sinabi nating oblique projection, we have two types, the cavalier and the cabinet. Okay, so in the oblique projection, this is a type of parallel pictorial projection in which projectors are parallel to each other, but they are not perpendicular to the picture plane. The angle is usually kept 15 degree to 45 degree, and this may be the two types. The cavalier projection, in this case, in the dimensions are along all the axes are plotted in full scale. And the cabinet projections, in this case, the dimensions along the diagonal axis are plotted by reducing it to half of the actual value. Dimensions along the other axis are plotted in full scale. So, the cavalier projection of unit cube, okay? So, ito po yun. Ito yung 45 degree, di ba? 30 degree. So, may pagkakaiba. Yan po yung cavalier projection natin. Okay, so sa cabinet projection of unit cube naman, ito naman, 45 degree, using the 45 degree, ito 1/2, 1/1. So, kung makikita ninyo yung differences sa cavalier, all along the axes are plotted in full scale, 1/1, 1/1, okay? But in the cabinet projections, meron na lang, half na lang siya. Half, 1/1, half, 1/1, okay? So, that's the difference between the cavalier and the cabinet projection. Okay, so let us learn the other projection. And this is the perspective projection, and it is a type of pictorial projection in which the projectors are not parallel to each other and they occur at angle to the pictorial plane, in which a way that they converge to a point as if an observer sees the view of the picture plane from that point. In case of perspective projection, observer is considered to be a finite distance, whereas a case of any other type of projection, observer is considered to be at infinity. So, as you can see, nagkaroon sila ng point dito. So, kumbaga, nagkaroon ng intersections sa lahat ng lines papunta sa isang point. And naging smaller din yung ating view. Hindi siya yung parallel na kung ano yung size ng sa object, yun din yung magiging size ng view. This is perspective projection. So, nagkakaroon ng scaling. Scale down or depende. Possible din yung scale up pero hindi side naman. Okay? but this time it's scaled down. So there are details of orthographic projections that we need to learn. Basically, the orthographic projection is any single projection made by dropping perpendiculars to a plane. In short, orthographic projection is the method representing the exact shape of an object or by dropping perpendiculars from two or more sides of the object to planes, generally at right sides to each other. Collectively, the views on this plane describe the object completely. And descriptive geometry is basically the use of orthographic projection in order to solve for advanced technical data involving the spatial relationship of points, lines, planes, and solid shapes. The most common means of understanding these types of orthographic projection is the glass box method. So what is the glass box method? So this is the method was used primarily for descriptive geometry problems. It can be suitable for understanding the generation of orthographic views. Key points of the glass box methods are the following. First is the user imagines that the object is enclosed in transparent box, said to be the glass box. And two, each box of the object is established on its corresponding glass box surface. And to obtain a view, perpendicular projections are drawn originating at each point of the object and extending to the related box surface. And the box too is imagined as hinged so that it can be unfolded to one flat paper. The box is unfolded to obtain the arrangement of the view. So in figure 7.6 below, mamaya, the vertical lines of sight A is the horizontal lines of sight B are assumed to meet at infinity. Okay, so that's the glass box method. So, yun yung tinatakal natin kanina. Then, are assumed to meet infinity. The line of sight is always perpendicular to the plane projection and represented by the surface of the glass box, top, front, and right side. The projection lines C connect the same point on the plane of projection from view to view, always at right angle. A point is projected on the plane of projection where its projector cuts the image plane in the figure 7.6.1, which represents a corner of the given object has been projected on the three primary image planes. And when it intersects the horizontal plane, top plane of projection, it is identified as 1H. When it intersects the frontal page of projection, it is identified as 1F, and where it intersects the profile plane, right side plane of projection, it is labeled 1P. So, okay, so let's, yung kanina binasa ko, okay, try to imagine this and try to figure out this. Okay, so as you can see, no, this is the vertical line of sight natin, and will be the top view, and this will be your front view. Okay, this is the front view, the right side view. This will be your projectors. So parang ginawa lang natin, this is the line, this is the object. This is the object. Then tinaas mo lang lahat, nagkaroon ka lang ng projectors pataas, nagkaroon ka ng projectors papunta dito sa horizontal line of sight, no? Dito din sa horizontal line of sight sa right. So lahat niyan nagkaroon ng projection. So you need the either the T-square or the ruler, no? Kung maliit lang naman, ruler na lang. Okay, ruler. Pag medyo malaki yung paper mo, you need to use the T-square. But if you are using just a long cotton band, you just need the triangle, you need the ruler for that. Okay? So, nagkaroon lang tayo ng mga series, mga multiple projections. Okay. So, eto na yon. Because nagkaroon ng projection, no? Ito na yung glass box method natin. Okay? this will be the glass box method. So, kinuha natin yung top, kinuha natin yung magiging front view niya, at kinuha natin yung magiging right side view. Make sure everything is align siya. Hindi siya pwede na itong front no ilalagay mo dito sa gilid, no? Kaya nga tayo nakalagay na top, meron dati ito yung front, ito yung right side view. Hindi pwedeng yung right side view nandito, kaya nga right side view. So kailangan naka-project yan lahat, okay? Naka-align siya well, okay? Dapat align siya ng maayos. So ito yung front view natin, magiging basis natin dito. Of course, this is the front view. Then ipo-project mo siya pataas. Pagka-project mo sa taas, dapat naka-align din yung circle, naka-align din yung mga lines, and ito din yung magiging sukat niya. Okay? So you need to use the right width, the right dimension, the right dimensioning, or the right lines, okay? The right measurement, okay? So ito din nagkaroon din ng projection. Hindi pwedeng ito magiging malaki to because so kaya nga tayo we will use the glass box method, and you need to use that right projection. So we have also the 6 principal views, and let us surround the object entirely by the axis of 6 planes, each at right angles to each other. On this planes views of the object can be obtained as is seen from the top, front, side, left side, bottom, and rear. Consider the object and its projections in figure 7.2. Think now at the 6 sides or the plane of the paper. The front is already in the plane of the paper, and the other sides are, as it were, hinged and rotated in position as shown in the figure 7.5. And the projections on the frontal plane is called the front view, or the vertical projections, or front elevation. And the projections on horizontal plane is called the top view, or the horizontal projections, or plan. Okay, and the projections on the left or right sides are called the left or right profile views, or left or right side view, or left or right profile projections, or left or right side elevation. And by reversing the directions of the side of the bottom view is obtained instead of the top view, or the rear view instead of a front view. Okay? So, hopefully, i-digest nyo to ng mabuti. In actual work, there is rarely an occasion when all 6 principal views are needed in one drawing, and all these views are principal views. Each of these 6 views shows of the 3 dimensions of height, width, and depth. In general, when the glass box is open, if we open it, its 6 sides are revolved outward so that they can lie in the between of the paper, and each image plane is perpendicular to its adjacent image plane and parallel to the image planes across from it. Before it is revolved around its hinge fold line. A fold line is the line of intersections between any hinge image planes. And the left side, front side, and back are all elevates views. Each is vertical, and the top and the bottom views, bottom planes are in the horizontal plane, but in the most case of the top, front, and right sides are required. Okay, so let's discuss this more with this figure. Okay, so as you can see, ito yung ginagamit natin kanina yung sa glass box. Okay, then if we will, will be the front. Okay, ito na yung magiging front niya. Then this will be the top. Okay. And this will be the left and right, then bottom, then front view. Pag inopen natin siya, eto na po yun. So, kung makikita ninyo, ito na yung top view, ito yung left side view, bottom view, right side view, then the rear view. So, here's the front. Okay. So, try to imagine this, and you need to learn for this because you will use this for your projects, and of course for your individual output. So this will be the 6 principal view by glass box method.